Hello guys, today we will understand how to write a Java program to check whether a given number is an Armstrong number or not. Right? How do we write a program for this? We will check. Before proceeding with the program, we will understand what is an Armstrong number. Right? For example, let me consider a number. Let me consider a number 153. I want to check if the 153 number is an Armstrong number or not. Right? So what Armstrong number says, when you extract the number into separate digits, so this is one digit and this is another digit and this is another digit, so three separate digits, and if you raise its power to the number of digits, for example in this case there are three digits in the original number, and if you raise its power of the individual digits to the power of number of digits, in this case it is 3, so I am raising it to 3. If you are going to get the same output, right, then the number is an Armstrong number. In this case 153 is an Armstrong number. So if you take 370, right, so 370 is nothing but you have to extract the number as 370, and you perform the summation. Before performing the summation, make sure that the extracted number is getting raised to the power of number of digits. In this case it is 3, it is 3, it is 3. The output is going to be what? 370. Right? If you say if the number 1631 is an Armstrong number, right, so extract the number 1631, right, perform the summation. Before performing the summation, raise the extracted digit to the power of the number of digits that is existed in the given number. So it is going to be 4, 4, 4, 4. If you check the output, it is not going to be the same as 1631. So this is not an Armstrong number. Right? So how do we write a code for this? So before proceeding with the code, and please understand this as well, if you are asked to check, hey, can you check if the number 2 is an Armstrong number? So what we are going to do, so you cannot extract this number, so obviously it is going to be 2, right? 2 should be raised to the power of the number of digits from the original number, which is 1. So it is going to be 2 itself. So this is an Armstrong number. Right? Hope you're able to understand the logic. Now let's understand how to build a code for this. How to build a Java code for this. Right? So let me scroll up. We will trace for the number 153. Okay, this is the given number. So let us take a variable name as num. So the number 153 is getting stored in num. First of all, we have to step 1. Step 1 is what? Please extract each and every digit. To extract the digit, we have to perform the modular operation with the given number. So the modularity operation should be performed with the number 10. Right? This is going to extract the last number, which is 3. So this is step 1. Right? The step 2, reduce the number from 3 digits to the 2-digit number. How do we do that? Just number by 10. Right? So number will be reduced to what? Number will be reduced to 15. Again go back to step 1. Perform the modular operation with the reduced number. Now it is going to be 5. Because we know that whenever we are performing modular operation, we get the remainder. And when we perform the division operation, we get the quotient. So in this case, the new value of number is 5. Right? So 5. So I'm sorry. when you do the division operation, it is going to be 1. So if you perform 1 divided by 1 percentage of 10, it is going to be 1, right? And again, if you do division operation with respect to 1, it's going to be 0. As soon as you get 0, what? Exit from the while loop. Exit from the while loop. Stop the while loop. So this is the simple logic. So we have taken two things. We have considered two things here. We have performed two operations here. One is this one, second one is this one. Right? Let us write these two operations. One is, this operation is called as extraction, extracting the single digit. Second operation is what? Reduction, reducing the number. Right? Perform this operation inside a while loop. Use the while loop. Perform perform the operation 1, which is extraction, and reduction, as long as the condition is true. As long as the number gets reduced to 0. In the beginning, the number was 153, and this reduction operation will make sure it is getting reduced to 15, then it is getting reduced to 1. At last, it is going to get reduced to 0. Right? As soon as it gets 0, this while loop gets terminated, right? So repeat the process as long as the number is getting reduced to 0. Right? This extraction will extract the last number. First it will extract 3, then it is extract 5, then it will extract 1. This will perform reduction, right? So meanwhile, in between the extraction and the reduction operation, try to perform the count. Try to count the number of times that while loop is getting executed. We need this count value. Right? If the while loop is getting executed for 3, then the count value is going to be 3. If the while loop is getting executed for 4, the count value is going to be 4. Right? If the count value is 3, it means that it is giving us the number of digits. So if the input number is 153, the count value is going to, it will make sure that we are getting number of digits. If the input number is something like 1600, the count value will make sure that it is going to give the count value as 4. Right? So we need to get the count variable. We need to get the count value, because with the count value we can perform the summation operation. Right? It depends upon number is 153, isn't it? We will raise the number to the count. So in this case, the count value is going to be 3. Right? So hope you have understood this logic. So after extracting the count value, one minute. So what we have to do? Let us go back and write the program. So I'm going to write a simple Java program here. Taking the integer variable as integer num equal to 153. So 151, or what was the number that we have taken for Armstrong? 153. Let us check if 153 is Armstrong or number or not. Right? So I'm going to pass this number to a method called isArmstrong. So this is Armstrong is going to take an argument which is num, right? So let me create a static method, static void is Armstrong. So let me pass the number here. Right? So let us build the logic in the static in the is Armstrong method. The first thing is we need to get the count. After getting the count, we have to perform the actual summation. How to get the count? So let me let me save this the input that we are getting in the argument in a new variable, in a separate variable called duplicate, dup. Right? Let me initialize the count value to 0. Let me also initialize the sum value to 0. So these are the two additional variables that I have taken to solve this problem, right? You will see when these variables are getting used. Firstly, I have to take the while loop. In the while loop, I have to perform two operations, right? So before performing the two operation, I need to check, I need to ensure that this while loop is getting executed as long as the condition is true. As long as the number is greater than 0, the while loop it keeps getting executed. So during the first execution, I need to extract the number. So for that, I am taking a separate integer variable. The name of the variable is extract, and I am performing modular operation. Extract operation. Then I am ensuring that the value of count is incremented. Then after this, I am also performing the reduction operation. Extraction, reduction. Number by 10. Like if you see this, initially the number, it is going to check, the while loop is going to check if 553 is greater than 0. Isn't it? Yes, it is greater than 0, the condition is going to be true. If the condition is true, it will go inside the loop. Right? The condition true, it will go inside the loop. And here it is going to extract. We have a variable name extract. This variable name is going to evaluate the given number, which is 553 with 10. Right? So in other words, we can say that it is going to extract the last number, which is 3. After this, the value of count is going to get increased from 0 to 1, because here the number will be reduced from 153 to 15. Right? Again, the control goes to the while loop. It will check whether if the 15 is greater than 0 or not. Yes, it is greater than 0. So it will come inside the while loop. In the while loop, it is going to extract the last digit, which is 5. So the count value will be increased from 1 to 2. Right? From here, 15 is going to get reduced to 1. Again, this while loop will check if the 1 is greater than 0. Yes, it is greater than 0. It is going to extract the last digit, which is 1. Count will be increased to 3. Right? From here, the number will get reduced to 0. So again, it will check if number is equal to 0. No, it is not. Number is not equal to 0. So the loop will be terminated. Loop will be terminated for the value 0. So 3 trues and 1 false. Right? So for each and every extraction, we are able to get the value of count. Right? Let us print the value of count to check if it is giving us right digits. Count. So count is 3, means since we are passing a 3-digit number, the count is 3. Let us say we are passing 4-digit number, the count is 4. So count is giving exactly the number of digits that we are passing, like number of digits that a number that the number has, that the input number has. right? So we were able to find the count, and again next we have to perform the summation. To perform the summation, again the same concept, extraction. So before performing this, now I am just resetting the number to what? Duplicate. Because the latest value of number is 0, so the actual number has got reduced to 0. This number has got. So again since I have already saved the number variable in a duplicate variable, I am going to resetting the number to the actual number, which is 153. Right? Now again I am start using the while loop. The while loop we will make sure that while loop gets executed as long as the condition is true. So here perform the same extract operation. Extract equal to number modular of 10. Right? Second one is what? Instead of count plus plus, here I need to do the summation. So I have already initialized a variable in the name of sum. So we will use the same variable name here. Sum equal to sum plus. So I am using a predefined function from Java. So I am taking the extracted variable, first extracted variable, and here I am passing what? Here I am passing count. So what does it actually do? It actually raises the power, raises the extracted power to the count, which means here the extracted number will be 3. 3 will be raised to count. The value of count is saved as 3 already. So because we got the count number here, isn't it? It's going to be 3. So it is going to calculate what? 3 to the power of 3. Right? So to be specific, it will be the value of sum is 0. 0 plus 3 to the power of 3, which is going to be what? 27. Right? The value of sum will be replaced to 27 in the first iteration. Right? So here it is breaking, the line is getting broken because the output that this method is going to give is a double value. So we need to do the typecasting because we are going to save this in an integer variable, right? So let's perform the typecasting. Casting it int. Right? So after the summation, then reduction, number equal to number by 10. Right? You know already this part, right? First number is 153, and after that number will be reduced to 15, then number will be reduced to 1, then the number will be what? Will be 0, false condition. Right? So in the extraction, first number is going to be 3, or second iteration it is going to be 5, and during the third iteration it is going to be 1. Right? So if you perform the same operation here, second time it is going to be 27. Latest sum value. Latest sum value is what? 27. 27 plus extracted number is 5 to the power of 3. 5 to the power of 3 is going to be 125, 35, 145, 152. Right? So this 152 will be, this sum variable is going to replace 27 with 152. Right? So the last time again it is going to the latest value of sum is 152 plus the last extracted number is going to be 1, isn't it? The last extracted number plus 1 cube. 1 cube is nothing but 1. So I can say it like 1 to the power of, just to be specific, it is going to be what? 153. So the latest sum value will be will be replaced with 153. Right? So now we have to perform the check. What check we have to perform? If DUP double equal to sum. If sum and the input is same, then just print what? Print the number is Armstrong number. So the given number is an Armstrong number. Right? As soon as this statement gets executed, just return, because I am instead of using else, I am just writing another statement, which is the number is not Armstrong. Right? If this condition is satisfied, this is going to be the output. Then as soon as the output is printed, it is going to, we have used the return statement, which means it will come out of the method. So this statement will not get executed. Right? If this if condition is not getting executed, this statement will be executed. Right? So let us test this. I am removing this count. We do not want to keep this count, have this count number printed here in the output, because our question is just to find the Armstrong number. So this is the input that we are passing on 153. Check if 153 is an Armstrong number or not. Let me run this. So the given number is an Armstrong number. Yes, it is an Armstrong number. And let us check if the number 122 is an Armstrong number. The number is not an Armstrong number, right? So if you take this, one more thing I need to mention. Instead of using math.pow, you can use your own function. You can write your own function. It's not going to be a big deal, but again it is a time consuming. So this power method is a built-in method. So in the time complexity wise, it is good and it is very powerful method. So you can go ahead and use this whenever you want to ensure that the number is power to a different number. When you have to raise a individual digit to a different power, you can use this inbuilt method. Even if you want, you can create a particular user-defined method for this to perform this operation. No issues. So this is all about the Armstrong number, right?